Hey, and welcome to the ProtoPod, the podcast for engineers, innovators, entrepreneurs, and trailblazers shaping the future. Here, we dive into the cutting-edge worlds of prototyping, aerospace, rapid manufacturing, high-velocity mass customization, and beyond. I'm your host, Jordan Rose. Today, we're talking with a founding member of the Canadian International Rover Challenge, Justin Gerein, a hands-on Mars-style robotics competition held each summer in the badlands of Drumheller, Alberta. He's an engineering manager at Calian Composites, a mechanical engineer by training, and a leader in designing high-performance composite systems, including one of the first QV-band carbon fiber ground station antennas. We'll chat about how CIRC is building the next generation of space engineers, the role of collaboration in failure and in innovation, and how Protospace is helping bring the rover designs to life. Let's get started. Hey Justin, welcome into the show. I'm super excited to have you on. You're wearing your CIRC hat, kind of spoiling the plot a little bit there is what we're here to talk about. You're a member of the board of directors of CIRC. Before we get into that, I just wanted to get a little background information on yourself. I know you're a trained mechanical engineer. Do you want to give myself and the audience an idea of your kind of professional journey through university and now working for Calian Composites?
Yeah, sure. So I originally went into university because I liked math and science in high school, and I didn't really know what I was getting into. But when I joined, I heard about this group called the University of Saskatchewan Space Design Team, and this is relevant because this has shaped a huge amount of my career. They were at the time doing the space elevator project with NASA. I'm like, oh, this sounds really, really cool. I want to do this. So I went to the first meeting, and they're like, no, we're not doing space elevators anymore. We're doing satellites. I'm like, well, this is really cool. I'll make satellites. So we did that for a couple of years, and the very first iteration of the CubeSat Design Challenge, the Canadian CubeSat Design Challenge. But partway through my program, after I selected mechanical engineering as my focus, we switched because the team composition changed significantly. We switched and we got over into robotics and things like that. So through all of that, I did a lot of like project management and design and things like that, which was really interesting. The one thing I knew I didn't want to do through all schools, I didn't want to do management, and somehow that's the one thing I've ended up doing a lot of. I didn't know what I wanted to end up doing, but I've ended up doing a lot of the one thing I didn't want to do. But through all of that created a big interest for me in space technology. And that's kind of how I ended up at Calian. It was a company in town here. They used to be known as SED Systems. They started developing some new antenna product lines, and that was space oriented, and it was something close to home. And I'm like, this sounds great. This sounds fun. And so, joining the USST really set me on this path of, an interest in space technology. And that's kind of, what I'm doing now. Moved into more of composites engineering, but supporting lots of different industries. But I started off after completing my degree, helping design and develop a large aperture carbon fiber antenna for satellite telecommunications. It ended up being the first QV band antenna to commercially operate at those frequencies. And that's turned into, a lot of design, a lot of manufacturing, different things like that, to start what was a non-existent division of Calian, being able to make this kind of stuff. We have a completely empty building, and sometimes it, surprises me to think about the fact I've seen this whole facility empty, and at some point someone's purchased every single thing that exists within this building, and I was a large percentage of those items. But did a lot of design analysis, helped with manufacturing, and now I've moved more into a management role where I do support the development of the different teams, business development, customers, things like that.
Very interesting. So definitely working for a very innovative company. Specifically, in your instance, you worked on an innovation with the communications for satellites, the antennas. I'm wondering how you became involved with CIRC. So you said that you were on the University of Saskatchewan space team, and now you are sitting on the board of directors. How did you become involved with the Rover Challenge?
Yeah, no, that's a really good question. So the whole event started, I'm sure you guys are very familiar. You're in one of the main sponsors of the University Rover Challenge down in Utah every year. So the competition we ultimately ended up participating in with the USST was the University Rover Challenge. So my fourth year of school, we went down and attended for our first time. And so the team kept going with that afterwards after I completed my degree and left. So one year, the team, as the URC continued to grow, the USST didn't get into the URC one year. So Austin Shirley, who was the president of the USST at the time, reached out to myself and some of the other USST alumni and said, hey, can you host a small event for us and a couple other teams that never got into URC, because we put all this work into building and designing our rovers. We still want to do something with it. So we said, yeah, sure, this sounds like fun. We planned out some tasks, built some simple things. It turns out, Protocase at the time, heard we were doing this and gave us a little bit of funding to help construct stuff to make it a little bit bigger than what we'd originally done. And we ended up with 2.5 teams attending, or at least that's what our joke is. It was 2.5 teams. There was actually 3 teams. So it was the University of Saskatchewan Space Design team, the Carleton Planetary Robotics team, or CPRT, and a team from Missouri. But it's half a team because the Missouri team couldn't get their homemade batteries over the border at the time. So they came to Canada and Drumheller with $500 in their pocket and built a rover out of parts from Canadian Tire. Definitely wouldn't pass our safety inspections now. But so yeah, it ended up as this casual thing for a weekend, in the parking lot and some of the parks in Drumheller. And we finished this weekend and we all really enjoyed it. Like wasn't intended to ever be this, ongoing and growing event that we've become now. It was just a casual thing to help our friends at the university do something with their rover. But yes, we turned around and said, hey, this was really good. Let's turn this into a whole event. So we took a really hard look at what we did and didn't like about different student competitions that all of us have participated in, and turned it into what is now the Canadian International Rover Challenge, or CIRC. But one of the biggest things we really wanted out of this was, how do we get all the students to interact and meet? That was one of our favorite parts about going to events, and that's something that Protospace has been a huge supporter and key component of, is Cirque Central powered by Protospace. And a single building where all the participants, get to spend the whole weekend at working 24 hours a day on their rovers and interacting and meeting with each other. That's really how Cirque became what it is now. And it's, looking at it and thinking about this, it's kind of crazy how Protospace and Protocase have been there from the whole thing, even when we were, 2.5 teams in a parking lot.
Yeah, no, it's great to hear that our company's sponsorship has made such an impact, and it's really the innovation that we hope breeds from these events, which we know it does, both in CIRC, URC, Spaceport, any student competition that we sponsor is really what we're looking to support, because ultimately those are the people that we support in industry, are the innovators. And that's kind of where I wanted to go with you. Is you were a founding member. You walked us through the journey from 2.5 teams to the competition now. And I'm curious as to how your own personal innovation in your professional career has maybe impacted, any initiatives or certain principles that you've instilled, I guess, on the competition, now sitting on the board, and what impact do you think that had? What lessons learned, I guess, could you provide to the competitors now?
Yeah, I think that's a really interesting question, because I think, when we look at what the competition is becoming and what it is evolving into, we see how a lot of things are affecting them. As an organizing committee, a lot of the things we do and a lot of things we want to try to instill and include in the event has come out of, what have we experienced in our personal careers that we wish we would have got out of the event. A lot of the organizing committee, again, very interesting to see this all comes full circle. Carleton Planetary Robotics team, or CPRT, a huge number of the team members that composed the team in 2017, 2018 are now organizers and are a big part of the team helping grow and drive the initiative. But I think a lot of the things we're doing now in terms of, we have more strict safety requirements and things like that. And the teams all have to write a report and demonstrate compliance and things like that. And a big part of that comes out of all of our personal growth in terms of, what have we had to experience in the workplace and what do we wish we had better and how do we just make the event more safe in general. I'm sure none of the teams of people writing the reports appreciate it right now, having to go through all of our requirements and demonstrate compliance and things like that. But that becomes a really critical aspect of what you have to do in a lot of engineering roles or project management roles or whatever these students end up doing, which is, determining how do we meet our customers' requirements, how do we understand our customers' requirements, and how do we demonstrate those requirements. And that's become a big part of the safety program, and how do we design for reliability and safety and things like that. And I think the other side of it, something that we've partnered with Protospace on the last couple of years, is the root cause analysis challenge, which we're super excited to be working on with you guys, because that's a huge part of what everyone does on a day-to-day basis in their careers, myself in particular, whether it's doing root cause analysis on a design that failed, or root cause analysis on why manufacturing flow isn't working, or root cause on why the proposal I gave someone, we didn't win that contract kind of thing. Mm-hmm. So being able to partner with you guys on that in terms of how do we get incentivize students to go through that exercise of looking at why they didn't do as well as they wanted, or why something failed in the field and things like that. So those kind of aspects of the event are hugely influenced by what we're all experiencing in our personal careers in terms of how we wish we would have developed a little bit more as students during these kind of activities.
Yeah, it's really interesting. I picked out one piece there that stuck out to me is what your customer is asking for, what we would term our customer's goal or our focus. Protospace kind of was all founded for innovators, by innovators, for their own needs, under this idea of high velocity manufacturing. We now call it high velocity mass customization. But the core idea there is that what really kills projects is latency. It's sitting around and waiting. It causes cost to balloon. Yep. You lose momentum, task switching, that sort of thing. And one of the key principles within that project DNA is how we enact HVMC internally in our projects. And one of the core principles to project DNA is goal, separating goal from hypothesis, and really understanding, hey, these are the requirements that have to be met. And then how do we get there in a way that removes as much latency as possible through, you brought up a really great example. I know it was for an unfortunate reason with the team from Missouri. But really what they did there was they came up with a duct tape solution is what we would call it. And it's something that's good enough that accomplishes a goal, maybe not quite well as it should have. But all these sorts of things are, very much not only what the company was founded for, but the reason why we love supporting these competitions, and likewise why the greatest innovators in the world come to us for these things, and that's really what it comes down to. It's that speed. I'm wondering, you had mentioned before talking about your role and the general, the breeding ground, I should say, that is kind of created at events like CIRC, and how you took an interest in space during your time at University of Saskatchewan. And I'm just curious if you can comment or have any thoughts on how you see CIRC playing in the aerospace industry in Canada. I know that we have former URC participants and former spaceport participants now founding companies in Canada. We have Nordspace, for example, and all of these folks working at various aerospace, both startups and established companies throughout the country. I'm curious as to see how you think CIRC fits in that.
Yeah, first I got to commend Nordspace and what they're doing. from their start, they've been very eager to support organizations, and they're a sponsor of CIRC alongside Protospace. They're doing a lot of interesting things. Um, yeah, I think there's aerospace, and there's just industries as a whole. One of the biggest advantages I think students get out of participating in events like this, and a big part of the reason we keep towards this is the goal is that this is an experiential learning opportunity. Part of it's the event itself, where they get to interact with each other and compete and things like that and see what other teams are doing. But the primary learning of the event is what happens the other 51 weeks of the year when they're not at the event. They're learning how to do project management, they're learning how to do design, to work independently and collaboratively and integrate subsystems. I remember one year we had a team show up, and their rover looked beautiful, it looked good, but they were in a mass state of panic, and we couldn't understand why. And we realized they hadn't actually integrated their robotic arm onto the chassis yet, and they had a whole bunch of overlapping variables between how they controlled the arm and the drive system on the vehicle. So they had to redo a whole bunch of their code so they could actually operate the two simultaneously, because at the start of the weekend it was lift up on the arm and the rover drove forward kind of thing. But I think that's the essence of that is through all this and through that 51 weeks of the year, and the intensive week at the competitions, you just kind of learn how to get stuff done. And that's a huge part of what goes on in innovation, whether it's a startup or trying to push change within an existing company. Is how do you get things done? How do you problem solve within the constraints and bounds of the resources you have? These teams and participants are not flush with piles and piles of cash and the luxury of a huge amount of time. So you really need to figure out how to get stuff done within the constraints that you have. And that's going to be critical for startups and innovations within Canada and robotics industries and things like that. I think one of the biggest things you get out of this is how much testing matters. Every year we get some new teams, and they say, what's the biggest recommendation you have for us next year to improve? And I think the common answer you'd probably get from all the organizers and volunteers at the event is build it early and test it. And that's one of the really unique things that ProtoCase and Protospace enable, is being able to do that rapid iteration and get those quick turnaround of parts and things like that. But that testing matters because quality matters. You get through your degree, and if you get 80% on an exam, you're happy. Everyone there's the common phrase, C's get degrees kind of thing. But 80% right at work or on an operating system isn't acceptable. Like 1 in 5 times, in our case, if your communication system works 1 in 5 times, that's one task where you don't get to drive your rover, and you really get to learn how to go through that intensive rapid iteration within the constraints of the resources you have. And that performance does matter in terms of your system and the reliability of it. And that's something you don't necessarily always get through your base educational programs. So that's, going to that experiential learning in terms of getting that experience it's what's going to create a huge amount of innovators and people that are starting companies or leaders within their organizations. It's slightly skewed opinions, but if I look at the individuals I participated the USST with, or other student competitions such as Formula SAE, those of us that were in those organizations have people are starting companies, they're following a very aggressive career path in terms of becoming leaders within the organization. So it's clear that participating in this sort of environment or competition or student group really enables you to develop unique skill sets that enable you to do things aggressively.
Yeah, no, I think that's very well said. And again, it harkens back to Project DNA for me, and it's, you talked about it, it's what we would call end-to-end moments and duct tape to get there. It's the idea of you want to get there as quickly as you can, run your system in full and test it, and then that kind of directs where you go from there, because you've kind of resolved the unknowns that you didn't know were going to happen. Oh, this bit of code doesn't work, or this arm isn't quite strong enough for whatever reason. And really, that is the key: is getting the product to finished very quickly, not done. And then you take it from that 80 to 100, and that takes you from finish to done. But I think that it's very encouraging that yourself and the other board members, committee organization team, the organization committee, I should say, are all kind of pointed, in that direction. I think that really bodes well and is encouraging for the students that get to participate in. And I do agree that that's something that we notice internally. Obviously, we hire lots of young engineers. We have to do innovation ourselves to keep up with our customers' innovation internally. Mm-hmm. And that is one thing that you notice is that the more exposure you get to project work, the more understanding you are and quickly can adapt to concepts like Project DNA that quite simply just allow you to move faster and end up with better quality at the end of the day. I do wonder, kind of in light of all of that, what your and the team's vision for CIRC is moving forward. I know you guys are growing, but where do you see the competition, in a few years from now?
Yeah, that's something we talked about as a team a lot, and I think it's kind of interesting because after our last event this past summer, one of our organizers, Jake Connor, had pointed out the fact that we make a lot of decisions along a consistent theme and a consistent set of values and objectives, but as we continue to grow, we needed to formalize this. So it's actually an exercise we went through this past fall where we sat down and Jake led us through that discussion of what are our values and objectives as an organization, and how does that affect us as we grow, and how does that influence our decisions. And two of the there's a list of things we came up with, but two of the ones that really stand out is how do we two of the big values that stood out were we want to create an environment and competition focused on learning, and we wanted to make it open and available to everyone. So we weren't restricting the event to the top performers. We weren't restricting it to people just geographically located in Canada. That's why it's the Canadian International Rover Challenges. It's located in Canada, but we want international participation. And we have teams from Canada, the U.S. predominantly, but all over the world, Europe and whatnot. But those were kind of our two primary guiding principles: is how do we create this learning environment, and how do we create it to be as open as possible. Like, our whole event stemmed out of the fact that a group of teams didn't get to participate in a different event because it was just becoming space constrained. And that's not a criticism of what they're doing. Obviously, we hugely admire what the University Rover Challenge is doing because our whole event is inspired and kind of based on what they originally created. But we wanted to, really focus and emphasize that learning environment. So our long-term goals are really focused on how do we increase the capacity for more teams to participate. And that kind of comes down to two paths forward for us. Is it a continue to grow into a single larger and bigger event, or do we look at, hosting multiple events? In February of 2024, Protospace, sponsorship enabled us to run our inaugural winter event out in Niagara Falls. We ended up not with a lot of snow and not very wintry, but it gave us a lot of thoughts around how do we continue to grow. So right now our focus is on continuing to grow the summer event. This year we're capped out at 27 teams. So over the next 2 or 3 years, the focus is going to be on how do we expand that beyond 27 teams. But how do we continue to grow that, and how do we increase our volunteer and organizer base so as that event grows, this can become a sustainable event for us as an organizing group, but also as that volunteer base grows, we can start looking at, secondary events or, full second events or smaller events to, encourage more testing throughout the year or things like that. But that's really our primary goal over the next few years is continued growth and hopefully getting to that 30-40 team count that we can actually support through the weekend on its own.
Awesome. I can't wait to see where it goes. I have no doubt that you guys will get there. I think you guys definitely have the right values, and sounds like you have a very strong leadership team. So I'm excited to watch. If folks listening are looking to learn more about CIRC for now or into the future, where would they find out more at?
Yeah, so most of our information about the event is on our website, which is circ.cstag or cstag.ca.
Okay.
That's where most information can be found out about the event, but we're all very active in terms of our general contact emails and things like that.
Awesome. And when is the event this year?
Yeah, so our event is always the second weekend of August, so that puts this year at August 8th to 11th, located in Drumheller.
Exciting. Not Martian, but Mars-like.
Yeah, Mars like with a bit of Martian grass.
Mars adjacent. Well, no, that's awesome, Justin. I can't thank you enough for coming on and talking about your professional career and about CIRC and what that competition has meant to you and what it means to Canadian innovation and Canadian aerospace. So, yeah, it's been a pleasure.
Yeah, thanks for having me, and thanks for like all of the ongoing and continued support from Protospace.
Awesome. It's our pleasure, and we can't wait to see where all the competitors go in the future.
Yeah, we're excited.
Awesome. Well, thank you so much, Justin. Until next time, bye-bye.
Thanks.